Hi, this lesson is going to be on working some problems with gases that are at standard temperature and pressure and molar volume and stoichiometry. This is the worksheet you'll need. It will work some of the problems and maybe you can find the other answers on my website. Okay, first notice we need to show your work on a separate sheet of paper, and when it says assume all gases are at STP, STP stands for standard temperature and pressure. Standard temperature is 0 degrees Celsius or 273.15 kelvins. And standard pressure equals 1 atm, or 1 atmosphere of pressure. Why those things matter is because when you change the temperature of a gas, you change its volume. Like if you heat a gas up, it expands. If you cool it, it contracts. And standard pressure, just, if you increase the pressure around a gas, it'll make it get smaller. If you release the pressure, it gets bigger. So we have to have parameters that set the temperature and the pressure. Now later on when we study gas laws, then you'll need to know other temperatures and pressures and how to handle those. But for now, we're going to say that all these reactions take place at STP so we can focus on the stoichiometry part. So the conversion factor that we're using is going to be molar volume, and molar volume says that 1 mole of any gas at STP is 22.4 liters. So let me show you how to use this in a problem. For number 1, for example, what volume would 2 moles of oxygen occupy at STP? Well, since 1 mole of any kind of gas, doesn't matter what kind it is, at standard temperature and pressure is 22.4 liters. So when you say that STP on your problem right here, that's just giving you permission to use 22.4 liters per mole in your problem. Okay, so the given in this problem is 2 moles. We're looking for what volume? So we're looking for liters. 2 moles of oxygen over 1. 1 mole of oxygen is 22.4 liters. Moles of oxygen cancel out, and you have 2 times 22.4, or 44.8 liters of oxygen. And I guess you could round that to 45 if you're being careful with your sig figs. Okay, how about, let's try number 3. That was number 1. Let's do number 3. For problem number 3, what is the mass of 44.8 liters of carbon dioxide at STP? So we get to use molar volume again. This time we're given 44.8 liters of CO2. And we're looking for mass, which is in grams. So you have to put 22.4 liters of CO2 on the bottom. That's for 1 mole because it says we're at standard temperature and pressure. And then the 1 mole goes on the bottom, and the molar mass, which is 44 grams of carbon dioxide, goes on the top. Then liters of CO2 cancels out. Moles of CO2 also cancels, and your answer should be in grams of CO2. And then our math is 44.8 divided by 22.4 times 44. So let's put that in here. 44.8. Hello. Helps if you turn your calculator on. 44.8 divided by 22.4 times for the molar mass, which is 44. The answer is 88 grams. We need 3 sig figs, so 88.0 grams of carbon dioxide. Okay, let's try another. How about, let's try number 6. Some people freak out because that one has scientific notation in it, but it's just a number. 2.4 times 10 to the 24 molecules of water vapor, what volume would it occupy at STP? So we're going for liters. We need molecules to cancel. We need to change it into moles. How many molecules are there in a mole? 6.02 times 10 to the 23rd. And then we need 1 mole of water on the bottom. And we're going to volume, so that's liters, 22.4 liters of water on the top. So the math is 2.4 times 10 to the 24th divided by Avogadro's number times 22.4 liters. So on my calculator, 2.4. Don't forget to get that 10 to the whatever. You're going to bump the second function and then the comma just above the 7 to get that little e. And then the 24. Don't put the 10 in or you'll have too many powers of 10 in there. So 2.4 second comma 24 divided by Avogadro's number, which is 6.02 second comma 23. And then we're multiplying by molar volume, which is 22.4 liters per mole. The answer is 89.3. So 89.3 liters. Which, I don't know if you recognize, that's, what is that? 2.4, I started to say, yeah, it's about 4 moles. I thought it was. But it's afternoon and my brain froze. There we go. Let's try a different one. How about let's go down and do number 9. On problem number 9, you're looking for the volume of oxygen at STP produced by the reaction of 69 grams of water in this equation. So there's my 69 grams of water changing to that and that, and we're looking for volume of oxygen. Okay, so the given is 69 grams of water over 1, 18 grams of water per mole. So we're dividing by molar mass. It's a 2 to 1 mole ratio, 2 moles of water for every 1 mole of oxygen. And then for every 1 mole of oxygen, we have 22.4 liters. Okay, so this is the given. This is the given over 1. This is dividing by the molar mass. This is dividing by the mole ratio, which I guess you would multiply the top, divide by the bottom. But these are the coefficients in the equation. And then multiplying times molar volume. Okay, and the calculator, this would be 69 divided by 18 divided by 2 times 22.4. So we got about, what do we want? 3 sig figs, 42.9 liters of oxygen. Okay, that was number 9. Let's do number 11. I liked this number 11 problem. On number 11, calculate the energy in kilojoules produced by the reaction of 100 liters of hydrogen at STP with excess oxygen. So what you're going to do is take your given 100 liters hydrogen, 22.4 liters for every 1 mole. And then what comes next? Mole ratio. Moles of hydrogen on the bottom. What are we looking for? We're looking for kilojoules. Oh, okay. So instead of just moles, we're also using kilojoules. And your hint was treat the 213 as a coefficient for the kilojoules. So the coefficient would go in here. So 213 kilojoules. There's 213 kilojoules of energy given off for every 2 moles of hydrogen. Like so. Check your units. Liters of hydrogen cancel, moles of hydrogen cancel, kilojoules doesn't cancel. So that kilojoules of energy, what we're looking for, we have 100 divided by 22.4 times 213. Whoops, I messed that up. 100 divided by 22.4 times 213, yeah, and divided by 2. Yeah, that's more like it. 475 kilojoules of energy given off in that equation. And let's do one more. Let's skip down and do number 13. For number 13, we're looking for density of carbon dioxide at STP. Remember, density, mass over volume, DMV triangle. We're looking for density, so it's mass over volume. But we don't have any numbers in there, so what are we going to do? Let's assume that we have 1 mole of CO2. So in other words, we're going to do molar mass over molar volume. Well, the molar mass of carbon dioxide is 44.0 grams per mole. Molar volume at STP is 22.4 liters per mole. Moles cancels out. Your units are grams per liter. And the math is 44 divided by 22.4. 1.96. 1.96 grams per liter of carbon dioxide. This is heavier, more dense than the density of air on average, and so you would expect it to sink. Carbon dioxide should be lower than regular air. I think that's right. So try the rest of the problems, check my website in case there's answers, and let me know if you need help. You can come in for tutoring. Thanks.